So just a quick background about me, not academic particularly. I did a master's degree in human factors and ergonomics, but then I've been straight into industry. So I worked in the rail industry for 3 years. Cirrus was a confidential reporting system for the railways, so that was lots of angry rail people phoning up to shout at me. Then I came down to London and did some work on the tube station upgrades, so station refurbishment, essentially telling London Underground you can't put a ticket office under the tracks, you won't be able to hear anything. And then I did a little bit of work on the Channel Tunnel rail link. I joined BAE Systems back in 2006, and I've had a number of roles within the company. First of all, I joined the Human Factors Shared Service, which is essentially an internal consultancy within BAE, working across different air products. Then I went for a stint on Eurofighter Cockpit Group. I'll go into all of these in more detail, and currently I'm in research and technology. So in this presentation, I'll just give you a brief history of human factors in aviation. I wasn't there, I don't know everything, but I'll just give you a bit of an idea of how things have changed over the time. I'll give you an overview about the aircraft. I'm only going to talk about the ones I've worked on because that's enough. A bit about the users. As a user group, fastjet test pilots and pilots in general can be difficult. And then a bit about the different projects I've worked on, so some sustainment of the Tornado aircraft, my time on Typhoon Cockpit Group, a little bit on F-35, which is the aircraft we've worked with America. I can't say too much about that because American military. And then the work I'm doing at the moment on future cockpit concepts. So back in the time, World War I, the focus was on selection. It was focusing on getting good pilots. One of the ways they used to measure this was how good you were on a horse. So that's the kind of level of selection they were looking at. But it was all about getting the person who could do that job, no concern to actually fit in the cockpit around the man, any of that kind of thing. And then a lot on training and just getting them trained and up there. As time moved on, cockpits got more complicated and good pilots wasn't always enough. So research done down at Cambridge by Bartlett, they started looking at the effects of stress and the effects of fatigue and performance and looking at how the different layout of displays and controls could actually help. And also a lot of more study on aviation medicine, aviation stressors. What is it like when you're flying that fast? What is it like when you're pulling those kind of manoeuvres? Post-war, 1970s, 80s, a lot of the work turned to the shift on human error, pilot error, blame the person at the sharp end, that traditional kind of good old thing. We just need to get better pilots, as someone once said at a conference I went to. And then more and more into the crew resource management. That's how they talk to each other, how they question each other, the feedback they get from each other on a flight deck. And they started to involve the users more and more in the design of the aircraft, but there was still no formal human factors team, ergonomics team, etc., etc. So you ended up with cockpits that looked a little bit like this. So this is what our pilots like to refer to as an ergonomic slum, where each different area, each different part of the aircraft would just put their controls where they thought they should go. So you had the fuel team going, mine need to go there, the engines going, these need to go here, and nobody particularly in charge. And then as things were added on throughout the lifetime of an aircraft, because fastjet aircraft these days, 40, 50 years in service, so they're constantly getting new upgrades, new weapons, new sensors, new technology even, just trying to bolt it in and fit it in. And the amount of times I've been told the aircrew will just remember that. It's fine, we don't need to work it, they'll use it. Which leads me on to the users. Now, this is one of our Italian test pilots. Typical. What can I say about the users? So I'm talking here about fastjet aviators. This is our old chief test pilot here, very modest man. He would describe them all as stable extroverts. They're willing to push things, they're willing to talk, but they are essentially not mad. As a user group, highly knowledgeable, very confident. They come across as very arrogant when you first meet them. I like to think it's because that's the way they've been trained. They have to get information across quickly and directly, but again, as one of the pilots said to me once, and then we go home and wonder why we're on our third wife. So there is that kind of very direct talking from them, but they are able to work in this complex high pressure environment. And we, as I'm designing the software, I'm designing the hardware, I'm designing the cockpit, I have to assume that it will be for a highly trained user. I have to assume that the RAF or the different air forces have done their job in training that person. It's not my job to train that person. I'm not assessing them. They're assessed a lot elsewhere. For me, it's about assessing the technology itself. However, we do have different nations and different cultures, so we have different levels of experience that different countries expect from their aircrew, so you can have differences. And you can also have differences of opinions. As we mentioned before, different countries read in different areas. In our cockpit, the warning system is a woman, but again, that's not because they listen to women, it's because that cuts through the noise. Most of the chatter is male, and a female voice cuts through, and her name is Bitching Betty or Nagging Nora, depending on what kind of mood they're in. So yes, so lots of different nations, lots of different cultures. Ultimately, when they all come together on one aircraft, as they did on the Eurofighter Typhoon, where we had the Spanish, the Italians, the Germans and the UK, they'd all come from different aircraft backgrounds. So some had been used to flying the American F-series jets, some had been used to flying the Tornado and the Jaguar in this country, and therefore they all had different ideas of how the information should be presented. So lots of compromises, lots of fights. So yeah, these are the aircraft I'll talk about today. So the Tornado GR4 has recently retired, but this was a twin-seat aircraft predominantly for ground attacks. So your Maverick and Goose, I guess, in your Top Gun parlance. Guy in the front, guy in the back, pilot in the front, weapons system operator or navigator in the back. It was developed in the 1960s, 70s. It did have software then, but it was in the kilobytes. It was only in the 2000s it actually matured to be about a megabyte and has matured since then as well. So that was two guys doing, well, I say guys, there are female pilots, they're just not very many. So I generally default to him. It's not for any particular reason. So two guys doing the ground attack role. Then the Eurofighter Typhoon came along, and this was doing the ground attack role and the air-to-air job, and they went down to one pilot. So this is where the computing and the autonomy starts to take over a lot more. So single seat, but it was developed in the late 80s, early 90s, so the technology is still quite old hat by our standards today. And it's expected to be in service till 2035, so we're constantly doing updates to this platform. The F35, as I mentioned, is this joint program with the US, again a multi-role one. Stoverly short takeoff, vertical landing, so it lands on the carrier. It's one of those ones. Recently entered the service with the Navy and the RAF, and again a single seat. Tempest is the name we've given to the next generation of aircraft coming out, which we're starting to work on now. So that's an in-service date of 2035. It's essentially going to take over from the Eurofighter Typhoon. But that's the development cycle we're kind of dealing with. Back to Tornado. As I mentioned, it's got limited computing power, and the work back in the day was traditionally done by the equipment engineers and the drawing office, the design office. There were no human factors or ergonomics or psychologists, God forbid, any of those kind of people in it. Which led to a bit of an inconsistency across systems. And as you can see here, no human factors but support by aircrew. I like to drag this out to show to the pilots and navigators of the Tornado whenever they complain about the HMI. It's a cockpit designed by aircrew for aircrew. Don't come shout at me. So back in, must have been 2006, we were asked to support the introduction of some secure comms, so new radios, and Link 16, which is essentially a data link way of sending messages across a network. So we put new equipment in there. Again, finding the space was quite difficult, so it was taking some old displays out, putting some new equipment in. The new equipment, we put a big TV in the back here that was actually colour capable, which was new for a Tornado. So that meant the design team went mental, making everything as colourful as possible. And there's us human factors engineers going, why is it red? Is it bad? Why is it red? Why is it green? Is that good? No, you're just using the colours. So we set up these HMI working groups where once a month we'd bring in some aircrew from the Operation Evaluation Unit at the RAF. We'd bring in our own flight ops because we have our own test pilots based on site, and we'd bring in the software engineers to talk to them, and we'd kind of mediate and make sure everybody understood what was going on. We also tried to put in place some philosophies, so crew task separation, who's doing what? What's the pilot doing? What's the navigator doing? Do we all understand that? How are we going to use colour? How are we going to do the warning system, etc.? And then we started doing assessments. There were some issues in that we didn't really have any facilities to do some of these. So when we introduced the secure comms bar, which is up here on the front, it's just been loaded on the top. One of the pilots just drove around the Perry track around our airfield with it on his car dashboard, practicing on a bit of cardboard. So quite high fidelity there. There was the whole stepping on toes issues. There were a lot of debates with the software team about what we're doing and why we're doing it and why they need us, etc. And there are also these issues of fitting in with the legacy. So I've just put this here to remind me. These are the navigator's TV tabs in the back, and they can do some data entry on this. However, when they were designed, if you press the top button, it would change it from A to K with no I in there. Because you'd never use an I because it looks like a 1, and that could be confusing for the aircrew. Similarly, they didn't have an O on the next keyboard because an O would look like a 0. So when it came to recreating it to actually do data entry, you have to use the 0 and the 1 on the numeric panel to be able to do that. So when we put this big display in the back, there was a big argument about, well, do we keep it the way it is with I and O on a separate keyboard, or do we put I and O back where they are in the actual alphabet? And honestly, it went on forever. We eventually had one very cross navigator going, I do know the normal alphabet. So yes, there was some resistance on Tornado. So while that was going on, also Typhoon was working over in the opposite building. So Typhoon was developed in the late 80s, and the Cockpit became a subsystem in its own right and had its own dedicated Cockpit group, Cockpit team. Originally predominantly human factors engineers, but over time more systems engineers, fewer human factors people. So we were establishing human factors as a real discipline. We had our own head of discipline, we weren't just part of mission systems anymore, we weren't part of software, we were a discipline on our own right. It was our responsibility to define, agree, specify and certify all aspects of the cockpit design with a pilot interface. So considering the human factors requirements and the operational requirements, what do you want this aircraft to do, what do you need it to do, and also the systems equipment capabilities. So cockpit design requirements, right data, right format, right time. So they introduced something called phase of flight moding. So you take up, when you sit in the cockpit before you take off, you've got one set of displays. As soon as you lift the gear handle, when you're off the ground, they change. So it's kind of trying to stop the pilot having to do lots of button presses in between, present the information at the right time. Minimise workload. As I said, we went from essentially a job that 4 people were doing to a job that 1 person was expected to do. So we had to keep workload within that pilot capacity. So bits of automation were put in there with various levels of success. Spread the tasks across the attentional resources and make it more manageable. So we put in a direct voice input. So instead of having to do everything manually on the international symbol for hands on throttle and stick, on the stick and on the buttons, you could actually talk to the aircraft. Again, different levels of success with that. Audio warnings, as I mentioned, Bitch and Betty. So initially, when we were doing a mission analysis of what do we want this aircraft to do, it was, well, is that something the system can do, or is that something the pilot needs to actively be involved in? We also wanted to enhance pilots' SA, so head-out operations pilots are really quite keen to look out and see if they're going to crash into anything. So we've got a head equipment assembly, it's called, so it's information presented on the helmet. So wherever they look, instead of just having a head-up display in front of them here, they take the information with them as they move around. And essentially, we were going to apply ergonomic principles and be tolerant to human error and all those kind of things. They're good requirements, they're really good requirements. So we had a traditional waterfall process. We would do some requirements capture, some analysis, some design development, etc., etc. And then we'd do some assessments. We'd have an ergonomics handbook, as I mentioned. We'll have airworthiness involved. We've got the mission analysis where we break down the task. We've got principles of cockpit moding going basically, this is how something makes its way onto the hands and throttle and stick. This is how important a function it has to be for it to be that quickly accessible. This is how many layers of button presses we should have. This is how many. Just standard guidelines to help people design for the cockpit. And we had, during the design usability acceptance, we would do formal assessments. A number of assessment facilities. So we've got the active cockpit rig, which is essentially a simulator. We've got a mission development lighting cockpit, which is real equipment. The ACR, the active cockpit rig, is a simulation, whereas the mission development lighting cockpit is real hardware. And then we've got an ambient lighting facility. So lighting assessments. As I say, yeah, displays, controls, all together with all the real stuff. So it's a big room we can wheel different cockpits into, and we can test at various lighting levels. Pilots generally aren't keen to do these kind of assessments because they can often mean sitting in the dark for a long period of time, just sweating in a cockpit, but things have to be done. So lighting assessments, layout assessments. Here's me in my flight suit, because we do check it on girls these days. So we could do this either on the production aircraft or in any of the simulators. Generally we use it now for any upgrades we do. Can we still reach it? If we're selling to a different customer, can their anthropometric range still fit in it? So we've all been measured. Luckily, when I was working in Cockpit Group, we did have a 95th percentile male and a 5th percentile female that we could quite easily drag in to come and do some of these assessments. Moding assessments, these are the more software-driven ones, so we'd actually get people in the simulators to fly. This is our control room, where we can see exactly what the pilot sees on their displays. We have a nice little air traffic control map, because we're going to pretend to be air traffic control, that's what we do. Some of us will play the wingmen, some of us will play air traffic control. It's all fun. Not after 10 weeks. And then this is a separate instrument panel where I can flag things in the data if I think it's interesting. I can segment the data and ask for workload scores after different bits. I can also, if I'm feeling particularly mean, fail things in the cockpit to up the workload. So these assessments consider usability from situation awareness, workload and human error. We just want to gather the evidence that the pilot can carry out the task with the information we've given them. As I say, we're not in charge of training, we just need to know, are we presenting them with the right information? So we did some assessments where they didn't take off, they were just sat in a cockpit in front of a blank display, and we flashed the display on and go, land it. Let's see if they could immediately get that information there. So an example mission, kind of things we'd make them do, we'd send them on an outbound nav and penetrate into hostile airspace, do an air-to-surface attack, do another air-to-surface attack, which someone had called in over the radio. Then we'd send in an air-to-air engagement to distract them while they were doing that, finish the air-to-air attack and return to base. So at each of these different segments, these are all just bits from that mission analysis I mentioned. We can say, right, okay, what was your workload at that point? What was your workload at that point? What was your SA like, etc. It just allows the pilot to segment things in their head, because these can last for about an hour. So asking them to debrief after an hour, they are quite good at debrief, but it still can be, it's good if I can talk to them and say, you gave a 7 for workload at that point. What was that about? It's just a nice trigger for them. Generally the debriefs do last as long as the mission themselves. That's just generally the way they do it. So as I say, the various measures were predominantly subjective measures, basic workload scores. We did have observers in the cockpit, so we'd put various things in the mission that they had to do, like check in with air traffic at a certain time, do a call sign correctly, various things, meet time on target. So we could tick things up performance-based, essentially. We could tick those off, but also we'd have an expert in the control room monitoring. We'd have someone monitoring from a human factors perspective. We'd have the systems engineer who designed that element, and if we could get them our own aircrew there as well to help, but helping out with assessments is quite low down on the pecking list after actually flying. The objective measures, the active cockpit itself takes logs, so we could get all the button presses, we could get all that kind of information. We know how long warnings went off for, we know how quickly they reacted to it, etc. And we started gathering eye tracker data as well. Post-assessments, because we have to do this with each of those 4 partner nations, plus with our own flight operations, so 5 different sets. We'd have what's called a wash-up meeting where they all sit down and agree the comments that will go forward, and then we bring all the nations back together to argue it all out again over the table. And the RAF always turn up with a lot more people than they need. I think they're just trying to psych the others out, but anyway. And then we provide evidence. We do a human factors presentation going, look, this is what we think. Do you guys agree? Do we think? You know, these are the recommendations we're going to take forward. So that's Typhoon cockpit assessments. F35, so this is new 5th generation aircraft, number of nations involved. I wasn't involved in the PVI, they call it a PVI in America, pilot vehicle interface instead of HMI. Okay, so it was done over in the States, so we did have some people over there, but the work I've been doing in this country has been integrating it with the other systems. So how does it land on the carrier, how does it talk to the other aircraft that we've currently got in service, etc, etc. New technology people are still not sure about. The F-35 guys love it, the pilots themselves absolutely love it, but if you try and talk to, say, a Typhoon pilot about taking away their head-up display or putting a touchscreen in, they're not sold. The F-35, again, because of the length of time it takes to get the software out, even though it is a touchscreen, you can see from this picture here, it's just single touch. There's no zooming, there's no anything like that. So you put a new pilot in it and they expect to be able to zoom and move things around. It's not multi-touch, it is just a single touch cockpit. But definitely a step forward. Right, the step after that, so this is what we're working on now. So this is some work we've been doing in research and technology on future cockpit. So we've put the man in the middle, it's human-centred. So we've put the human in the centre. I did ask for a female pilot there, but apparently we don't have any images of that. I asked for a female mannequin a while ago to put a flight suit on, and apparently no, they don't exist either. Anyway, so the idea is the pilot, it's going to be a software reconfigurable wearable cockpit. So the new generation of helmet, as I said before, it gives you the head-up information. The next generation is fully colour capable. So why have actual displays in the cockpit? As I was saying, it's difficult when we want to retrofit something. We want to try and find an extra button, find an extra display space. If we put it in the software and we just display it in his visor, then we can upgrade it whenever we like. It's just software. And as the pilot looks down into where the cockpit would be, it's presented there to them. But if they're looking heads out, they can still see heads out, and we can start to augment information over the top of the outside world. So they can see the outside world, but what traditionally would have been presented on a 2D display. So for example, these domes here, missile engagement zones. So traditionally you'd have them on your head down display and you'd have to work out in real space where they were. Let's just put them on the outside world, so the pilot looks out and he knows that if he goes into the yellow they'll see him, if he goes into red they'll see him and shoot him. You know, that's information you might actually want heads out. And again, it allows you this flexibility of whatever displays you want, you can put them where you like, you can set it for you. There's a lot of information, especially we're expecting in the future battle space, all the information coming back from unmanned vehicles, all the information coming off data links, etc, etc. There is a potential to overload the pilot with information. So it's all about how do we present that information at the right time. Using the new generation technology, how do we do that? So one of the things we're building into the helmet is eye tracking. We know where the pilot's looking because we know where to present the data. But if we can use the eye tracking as, do you know what, don't put what type of aircraft it is on everything out there. Just do it when he's looking at it. Just, you know, mode the information based on where they're looking. So Benefits of eye tracking as well come into this cognitive feedback aspect. Can we start to monitor the pilot? Instead of just monitoring the aircraft and the health of the aircraft, can we monitor the pilot and start to understand more about their stress levels, what they're coping with? As we're building more autonomy into the cockpit, it's this idea of the adaptive autonomy. If the aircraft knows when you're getting stressed, it knows to take over some tasks from you, which again brings you into that whole, well, how do I know who's doing what, which is an interesting challenge. And this is where we get into the idea of, well, how do the human and machine talk to each other? How is that an avatar? Is it someone where you can see the face, or is it a Twitter feed where you can like things and dislike things, and the aircraft learns that way? We don't know, but there's lots of interesting things to look at. Haptic feedback, we've done a little bit of a play with this. The gloves that we've tried aren't really great at the moment. They kind of just vibrate the end of your finger. But traditionally in aircraft, haptic feedback was really good because you had lots of banks of buttons, and you could just do it by touch. You could reach behind you and just feel the different tops of the buttons, so you knew which one. The idea is that the cockpit's filled with smoke, you can still identify them. Do you need that when you've got a visor and you can just move your display there? Do you still need that haptics? Discuss. So how do we get there? So we've been to lots of wearable technology shows and universities, and said, what do you think? What do you think of the next technologies? What do we need? What can we have? Just buying gaming technology off the shelf stuff. Can we get it in? Can we try it? Can we get it quickly in front of pilots and do various things? So we bought various bits of monitoring kit, but also HMI kit interaction stuff as well. So we've done some various experiments in the lab. So this is just a simple selection task. So we got people to do different selection tasks with different technologies. How easy is it to do it with the eye tracker versus how easy is it to do with voice versus how easy is it to do with a traditional button? How easy is it to do with a games controller? Totally depends on how old you are, because we got the printouts of how people got to the different buttons, the different tracks they had to select. I think most people under 40 just went diagonally straight down, whereas most people over a certain age went across and then down, because God forbid you move the games controller in a different way. But it's the generational issues that are really coming to the fore at the moment. But all the time we're doing this, we're having to consider the aviation environment and the aviation stressors. You could put stuff all over the pilot. They often talk about wanting an iPod or something on their knee, but what happens in ejection? Does that smash and break your leg? These are the considerations we have to put up with. What happens under G? Gesture control, really good for manipulating 3D displays, but you're not going to do it in high G. Your arm weighs far too much. Vibration, not as much of an issue, because actually the vibration in fast jet cockpits isn't that bad. We actually did a trial where we compared the vibration in a Typhoon with one of our colleagues driving along the M62 in a Ford Focus, and that was a lot worse. So not that much of a concern, but it is when it thinks about sizes of buttons you need to have in the cockpit and things like that. So, issues. One of the major issues we're having at the moment is, what will the missions be in the future? We don't know. We don't know what the war's going to be fought in the future. There's a tendency to design for the previous conflicts. We don't necessarily know what the battle space is going to look like. What will be the threats? Identifying new technologies and processes. We're trying to work in an agile way. We're all trying to be scrum masters and product owners and doing that. Physiological monitoring is a whole new thing. The pilots are actually quite okay with it at the moment. They've got some pulse oximetry watches at the moment. I'm constantly getting inundated with, hey, look at my data. Brilliant. Machine learning and AI. When we're starting looking at the physiological measures, the EEG caps we're using, if they've got 24 channels and recording at 500 hertz, that's a lot of data that I don't want to analyse. So can we give that to the machine learning people who are desperately crying out for numbers to crunch? So that seems like a good way forward. What are the pros and cons of the virtual versus an augmented cockpit? What's it like being in virtual reality for that amount of time? How does that adjust when you land and you have to drive home? Human autonomy teaming. How do we split the tasks? How do we keep the human in the loop, not on the loop? It's quite difficult talking to the operators, because they will still go, but I'll still need control of my radar. No, maybe the computer can work it out better than you can. No, I will still. It's still trying to get them to that new How do they get to this trust, like we were saying before? Is how do we measure trust? How do we build that trust? Do you train with your AI? Do you train with it along? How do you get that camaraderie you get from talking to somebody in the bar after you've been out on a sortie? How do you build that trust like a pilot would have in his navigator, hopefully? And yeah, how do the aircraft and the system communicate? When we're looking at the physiology, can we tell the difference between what is a cognitive stress and what is an aviation stress? And what are the ethics of monitoring our operators? And how far do we take that? If we can fix your eyesight to 20/20 with laser surgery, why don't we make it better than that? Where do the ethics come in augmenting the human going forward as well? It's all a brave new world that we're chipping away at and asking the questions. So quickly in summary, battle space is becoming so much more complicated and the information is increasing. Luckily, we are more involved as human factors people. We are a lot more accepted, if not so much by the engineers, but by the air crew and the end user. So that's quite nice. So we're involved in the design assessment from the very, very early stages. We're asking the questions, how are you going to use it? What are you going to do at the same time? Just do that human-centered approach from the beginning. The new technologies are giving us different challenges, but also potentially solutions. The use of psychophysiology might just, adaptive autonomy is way out there, but we can use it in a lab. If you put a fast jet pilot in front of a design and say, what's your workload? They generally give you a very low score because they're very capable, or they think. If I can actually measure it objectively, I might get a different answer from what they like to give me. But overall, it's very exciting. It's challenging, it's interesting, and there's just loads to do. And that's it. That's my rant.